The cardboard computer is back again. If people didn't go to formal, they didn't get one of these. If you didn't come last month, you didn't get one of these.
Is this the same one you had last month?
This is not the same one. This is from formal. This, however, is what I passed out last month, and if I don't have enough for everybody this time, these are the ones that are left over, so if you didn't get one before and you want one, they're up here at the front. This is cardiac, in its opened out form. It normally is the top is folded down, and then it can close up and be put away. It's operated by these sliders that go up and down. Oops, malfunction because it doesn't have the right environment. So these things go. Woo, put it on the video, right? Cardiac is not a general purpose computer. Cardiac is not meant to do any kind of real computing, but it is meant to give people an exposure to how computers compute. And my hunch, based on personal experience, is that people that get a chance to play with this either are intrigued as hell and get into it and go to the extremes that Skip and a few of my students went to in terms of writing programs for it, or they're just bored and they look at it and say, oh, that's all it is, and they're done with it. That's the end of the experience. In any case, either extreme, there's some in the middle, but it's usually, I think it's a bimodal distribution rather than one in the middle. And from some of the things that I said in this little paper from formal, there a lot of the stuff in the original manual. This is the manual that goes with it, and you're welcome to take a look at that. Actually, let me just start this around at this side, and this around at this side. Pass it around and see what goes with it. It's a little outdated, and so I'm working on upgrading it, and hopefully, if everything goes right, we've got permission to publish it, if everything goes right. There seems to have been some mix-ups. Skip could probably address that issue a little bit better. Do I say a couple things?
I got a call AT&T to find out what the status of the thing is, and told them that we were interested in using it for education purposes. Could we get the rights to republish it? And they sent us a letter from their lawyer saying we now have the rights to it. And ever since then, John has been sort of trying to figure out a way to get this thing actually done. This physical one he's got here is been our best bet because it gives us the ability to see the inside without taking the one that I both got nested apart. In the meantime, I think it was Kevin sent me an email. Was it you? Somebody sent me an email.
What did it say?
About a company in New York selling it, and they believe they have the rights. And without trying to get lawyers involved, my presumption is that AT&T is big enough to provide an entity that collects members of what they're doing. And that both of us have reason to believe that we own it. So we are not any kind of anything being stolen. So we're going to negotiate with them into some kind of arrangement.
Does your lawyer say you have exclusive rights?
No, that's our lawyer wants to see.
Aye, there's the problem.
And the tie-in to fourth, the very last things that I'm saying, that the neatest thing about this, or one of the really neat things in terms of programming it, it's only got add and subtract instructions and the jump and branch and so on. But it illustrated the bootstrap process, where there is no ROM that has a program in it. The early computer stuff in the 60s, you downloaded it from something into the active RAM memory. And in the computers I worked on, it was from paper tape into the drum, and the drum spun up and you went on. But that bootstrap, it was fun, great art to try and make as small a bootloader as you could. And the Cardiac thing had a one-instruction bootloader, which was fascinating when we figured out how it worked. In the new way that I wanted to do things, to more closely illustrate today's architectures rather than the 1950s and 60s architectures, it looked like I was going to lose that ability. But I pulled a hack and got around it. It's a memory accumulator architecture so that everything talks to memory. And in today's version, I made the I/O also be memory mapped. When it boots, it starts up in location 0. And it starts executing there. And there's a hardwired instruction there that says load the accumulator from address from 01, which is the input port. So I made this be the port. The I/O port is mapped into address 1. And with the assumption that whenever you read something from address 1, you're going to get whatever is available from the I/O port. So the machine, when it first starts up, it loads into the accumulator, it reads address 1. Then it comes down and it's going to execute whatever the next input is from address 1. Executing or fetching an instruction is physically the same thing as reading data from an address. So the CPU, the core part of this thing, the state machine, is going to fetch the next data from the I/O port. And instead of treating it as data, it's going to treat it as an instruction. Again, getting across that there's no difference between how a computer deals with numbers. They're just numbers, whether it's an instruction or data. So it reads an instruction, and the first instruction that it's going to read is going to be to store into address 2. So the first thing it does is load whatever's on the input. Whatever's in the input stream is going to load the first one of those into the accumulator. Then it's going to store. The second thing in the input stream is going to be a store into O2. And so when it's executing this one, it stores the whatever it read here into location 2, and this is just going to be a jump to location 1. Okay, this is a jump to location 0. This is a boot program. These two instructions, beginning of your program, but this is program and address. Actually, let me say what that is in a minute. But this hooked up with having forced in here a load 01 is enough to boot the system.
What do you have in number 1? What have you written in that first?
I put I/O. This is the I/O port.
Okay, so the first instruction in the I/O stream.
The first instruction in the I/O stream is a jump 0. That's the first piece of data in the I/O stream. The second piece of data in the I/O stream is a store into location 2. So it goes. The first instruction is to load address 01, which is an input instruction. It's reading from the I/O port, and it loads that into the accumulator. And then the second thing, it executes the next item in there, which the instruction is store the accumulator into address 2. And this first piece of data is a jump to 0. So in here is it go back to there. It's going to load in the next thing here, and this will be a data, and then what follows after that is a store into its address. So the rest of the program, the boot that you load up, is a sequence of pairs of data followed by a store instruction to the address where that data is supposed to be loaded. And so it's just a whole bunch of pairs. It's bigger. It's twice as big as your program really is. But for small programs, this has got 100 memory locations, that is the job. It's just a sequence of pairs. And a neat trick, which Will Baden may have taken to heart, was okay. What would a program look like that would actually let you have your program just be all data? So it would take account of how many words that you want to store, and then the list of them, and how big a program. And I actually wrote it up. It's about 10 instructions long is all it is to add to this. Then I came up with this other hack, is that what happens if what I do is have a data that is a jump to 01, and then I store that in 02. If I read in that pair of values,